Imagine you are using banking application to transfer money. While the transaction is being processed, another customer is applying for loan. Someone else is checking their account balance. Thousands of users are receiving transaction notifications at the same time. Just think if all of these features were part of one massive application, a small change in one feature could require redeploying the entire application, or a small change can break the entire application, right? So, how do enterprises handle this situation? The answer is microservice architecture. In this session, we will understand what architecture is, how it works, and why it's one of the most popular architectural styles, right? So, microservice architecture is an architectural style like other architectural styles. Most of them we have already covered in the earlier sessions. Please take a look at the series. Now, a microservice architecture divides an application into smaller independent services. Instead of one large application, it divides the application into smaller modules. Right? This is one service, right? S1, S2, S3 maybe, right? So one single application is divided into multiple services, right? All together becomes one application, right? This is one application. Application is divided into multiple independent services. Each service is responsible for a single business capability. Example, in large banking application, we can have one service for customer, right? For handling the customer data. One service for accounts. One service for payments. One for loans. One for transactions and notifications each, right? Here, each service has its own business logic and communicates with other service using APIs. Let us understand this with an example. As stated at the beginning of the session, a customer, say the customer is trying to transfer 10,000 rupees using mobile banking application, right? That is a problem statement. Now, what happens? There is a user. User is trying to transfer money, right? 10,000 rupees. Now, the first call goes to API gateway, right? Now, don't worry what is API gateways. For now, just understand it is the bridge between the user and the backend system, right? If required, we'll make a dedicated video on API gateways, right? As of now, it is just a proxy. What happens in API gateway layer is a user request is scrutinized and screened to have validation or to allow only certain number of calls against backend, right? Or to transfer the request to different formats or responses to different formats. These are all the capabilities generally we can have an API gateway, right? Now, from the API gateway, this is our, say, banking application, right? Banking application. It has different services. So once the user makes this request, the request is landed at API gateway. The very first thing that happens in, say, any application, right? The user identification, right? To identify whether a legitimate user is making the call, right? So what happens? The call goes to auth service, authentication service for user identity verification. User provides his username, password, details, and it verifies whether the user is genuine, right? Now, account service. Now, auth service job is done. Now, the next service is account service. Account service. What account service does? It checks available balance, whether the user has sufficient balance in the account, right? If the user has sufficient funds in his account, the payment service processes the transfer from account A to account B, right? Now, the transaction service records the transaction, right? The transfer has been done. Now, the transaction has to be recorded. The transaction service records the transaction, right? Now, last, notification service. Notification service sends the SMS or email or push notification to the user confirming the transfer is successfully completed, right? This is our banking application. Now see, the large banking application is divided into multiple independent services, right? Each service is responsible for only one functionality. Authentication is only dedicated for user authentication. It does not check the account balance. It is not responsible for the credit or debit, right? So each service has its own business logic, has its own database, right? It is independently deployable. Each service is independently deployable. Change in this service will not affect the other service. It can be modified, deployed, and it can have its own database. So this is the flexibility that the microservice architecture gives, right? Now, it provides scalability, right? Now, if we want to add another service, say, if we want to track the um, usage habit of a customer, right? Maybe summary of his transactions, right? Summary of his transactions. Yeah? We can independently add to the banking application, right? This service is independent of all of the other services. Now, adding this should not affect any other services, right? And changing any one of this should not affect any new services as well or existing services, right? If at all, if the summary has to get the data from transaction service, then it makes a call through API. It calls the API and exposed by transaction service, gets the required data, then update it database or process the transaction and provide with the summary of usage habits of a customer, right? And the microservice architecture helps in faster development and deployment, right? Now, since everything is independent, it is easy to develop independent features. There is more clarity, architectural clarity. There are less decisions to make, right? We don't have to worry about how this affects other functionalities, right? When we are building auth, we can only focus on auth functionalities and behaviors, right? So one at a time. It also provides better fault tolerance, right? Since each service is isolated from each other, if notification service fails, money transfer may still complete successfully, right? The notifications can be retried later. So all are independent. Though they are belonging to the same application, the services are independent, right? Now, what are the some challenges that microservice architecture poses, right? So, since there are multiple services to handle, it increases the operational complexity. Managing many independent services requires robust monitoring, logging, deployment pipelines, and service discovery. There has to be set of APIs exposed and how they are used by other services, right? And there has to be independent deployment pipeline for each service. And if one service, for example, if payment service fails, right? Now we have to check where exactly it is failing. Whether it is failing in auth, the user don't know, right? Whether it is failing in accounts or payments, right? So we need detailed logging and monitoring. And each service has its own database. Maintaining the data consistency across services becomes more complex. The same user needs to be updated in all the databases. The same payment data needs to be updated to transactions and notifications, right? And it adds communication overhead, right? Because every service is talking to every other service using the APIs, right? If the summary service needs data from the transaction service, then it has to request through API, right? It cannot directly communicate or it does not have code or functionality of transaction. It is independent, right? It has to come through the API. Same for payment to transfer. Every other communication happening between individual service is through APIs. So, in nutshell, microservice architecture divides an application into smaller independent services, each responsible for specific business capability. Right? This enables independent development, deployment, and scaling, and make it an excellent choice for modern applications. Right? Microservice architecture is not about making applications smaller. They are about organizing software around business capabilities so the teams can build, deploy, and scale independently. This session is part of software architecture series. There are more sessions covered on different topics of software architecture. Please take a look. Thank you for your valuable time.